Audio Jungle. Audio Jungle.
Fine. So, guys, today we'll talk about the conservation equation. So, conservation equation, right? So, how many conservation equation we have? So, we have basically three conservation equation. First one, it is called mass conservation. Mass conservation. Second is called momentum conservation. And third one is energy conservation. So basically we have three conservation equation, right? So question based on this they are asking. Now this mass conservation also called as continuity equation. What it is called? It is called continuity equation. Okay. You might heard in fluid mechanics, right? So this conservation, mass conservation called as a continuity equation. Continuity equation. Okay. Similarly, this momentum equation, which is also called Euler's equation, or Navier Stokes equation also you can say, right? There are different condition. With different condition, it is called Euler's equation. With different condition, it is called Navier-Stokes equation. Okay, but it comes from the momentum conservation. All right, and third one is nothing but is energy equation, right? And you know that like Bernoulli equation and all comes under energy conservation. Fine. So one by one we have to talk. First we'll talk about the mass conservation. Okay. So if you talk about the mass conservation equation, so we have a different format for the mass conservation or continuity equation. Okay. This is very important. Okay. So now this continuity equation will have to write in different format. So what are the different format? Like continuity equation in vector format, continuity equation in differential form, continuity equation in integral form. So one by one I will write. Integral form. Okay, continuity equation in integral form. What is the next? Next is continuity equation in differential form. differential form, yes or no? Then we have continuity equation in continuity equation in vector form. Okay, these are the different format to write the continuity equation. All right, and obviously we'll talk about the continuity equation which is frequently used continuity equation in Cartesian coordinate. Okay, Cartesian coordinate. Polar coordinate. Then last is continuity equation in polar coordinate. All right, so these are the different format. Okay, continuity equation in integral form, continuity equation in differential form, continuity equation in vector form, continuity equation in Cartesian coordinate, and continuity equation in polar coordinate. So basically these are two very important last two, Cartesian coordinate, because that physical I mean like you have to use Cartesian coordinate for the calculation, for the numerical purpose. A Cartesian coordinate you have to use that continuity equation, and sometimes polar coordinate also required. Okay, so you have to use that. Fine. Now, so first I will tell you like what is the integral form and how to get that equation. So all the format not required to derive and all, but in short I will tell you. Okay, because you must know about the continuity equation. So question will be asked to you. First of all, it is based on mass conservation. Okay, continuity equation based on mass conservation. So I will write continuity equation in integral form. In integral form. All right, continuity equation in integral form. How to get that? Check. Now you can say this is the one system. This is one system. Okay, and for this system we have a control surface. Okay, this is the one control surface. In short, I will explain. Don't worry. This is the one control surface. Okay, fine. And that control surface, it is nothing but ds. All right, and definitely if you talk about the full volume of the system, so volume of the system is nothing but v. Yes, all form essential to remember. Okay, because question will be asked to you. So this is the volume of the system. Okay, this is what elemental volume. Okay, Now to take the small section, okay, and suppose this is the system here. So you are taking this small volume part, and this small volume is nothing but dp, okay, n vector, perpendicular to the area, because ds is what? Elemental area. What is the ds? Elemental area. Now we think about the okay, this is the whole thing. Now for this system, again I just simplify the diagram so it will be more uh, easy to understand. Suppose this is one control volume, in this way you can understand, okay, just think about it. All right, fine. Now suppose for this vessel, this is the one vessel, okay, and for this vessel, that this is the liquid. How you are getting the liquid? Because you are filling this liquid, okay, you are filling this liquid, no? Now two things you have: one, you can fill it, or that fluid is what going out, okay. So because this is the water here, check, this is the water is already filled, so you are not going to fill, that water is what going to outside, it is already filled now. This vessel is already filled here till here, okay, just think about it. Now as I told you, small, this is the control volume of this vessel is nothing but v. This is what? Volume of vessel, okay. Now just think about it. There is the small hole. This is the small hole, and this is nothing but ds. Yes or no? This is nothing but elemental area ds. There is the small hole. So from this small hole, what will happen? That water will come down. That water will come out, right? So water outflow. Yes or no? When water is what going out from the vessel, then what will happen? Inside this volume of the water is what going to decrease. Yes or no? Because water is what going out. At the same time, another diagram also you can draw where water you are filling. So that time, check, just try to understand. It's very simple, because this diagram, it is perfect, no problem. It is given in Anderson, no? John D. Anderson Fundamental of Aerodynamics. This derivation is given properly, and I'm teaching the same derivation from that book only. But the thing is, to understand by this diagram, it is sometimes difficult for the learner. So for you, it will be very easy to understand. For that reason, I have drawn this diagram. Okay. Otherwise, this one is perfect, na? Control volume. This is what control volume. Fine. Now, so in this case, what you are doing here, you are filling this vessel. So if you are filling this vessel, so definitely there will be one elemental area you have to take, or you can say small hole. So from this small hole, that water is what filling. Okay, anywhere you can take. I think this should be uh, it. And this is the small hole, right? I mean elemental hole, circular hole, you can say. And now water you are getting inside. You are getting water like this. So what will happen? That volume will increase. Yes or no? So you can say here you have increment of mass. Increment of mass in control volume. Yes or no? Because water is what? Inflow. Water is what? Inflow. So you can say there is the increment of mass. Yes. I must write in short. So mass increment in control volume. Why? Because it is filling. Okay. And it here water is what going out. So what will happen here? Tell me. Simple. Mass decrement in control volume. Yes or no? It's a very simple, common thing. All right. Now, based on this, you have to draw because continuity equation is what? It is the mass conservation. This continuity equation is what? Mass conservation. Mass will be conserved. Whatever mass of water it is entering, the same mass of water will be incrementing inside the control volume. Simple. For the second diagram, whatever the mass of the water is what going out, the same amount of mass of water will be going to decrement. Simple understanding only. Hope it is clear to all, right? Now, based on this, we need to write the equation, integral equation for the mass conservation. So, what I can write? What is the mass? Simple. Mass per unit volume is nothing but density, right? What is the mass? It is density into volume. Simple. So, mass is nothing but rho into V, right? But mass in one case it is, check two diagram you have. In one case mass is what? Decrement. In another case mass is what? Increment. Yes or no? So in this sorry, in first case mass is what? Increment because it is filling. And in second diagram mass is what? Decrement. Why? Because water is what? Going uh, outside, right? So this is the figure 1 and this is figure 2. Any figure you can take and you can draw the, I mean you can write the equation. So I will take figure 2. For figure 2, so mass is what? Decrement. Yes or no? So what you can write? rate of mass decrement, okay, rate of mass decrement within control value. Yes or no? That mass of what I have written, rate of mass decrement within control volume. In the second diagram, check rate of mass decrement. Why? Because water is what going out. Water outflow is there. So rate of mass decrement. Why it is rate? Rate means per unit time, and obviously because if you open the wall, that suppose here this, maybe this is a small gate, if you open it, so it will take time, right, to flow water outside, and that level of water whatever it is filled, that decrement volume will change, volume of water will change, and mass of, you can say, mass of water or mass of fluid will decrease, but it will take time. So that's the reason, maybe 2 minutes, 30 seconds, 4 minutes, 5 minutes, or 60 minutes, or 45 seconds, but it will take time to empty the vessel. So rate, that's the reason rate. Rate means per unit time. So rate of mass decrement within control value. So if you write rate of mass decrement, then what is the mean? First of all, decrement means negative. Decrement means negative. So I have mentioned decrement, which is negative, and rate means per unit time. So dou by dou t, and you are going to write mass. Mass within control volume. Control volume. Yes or no? So little bit I'm going slow so that you can understand, because this is very important. Okay, fine. Now minus dou by dou t. Dou by dou t means rate per unit time, means that is the rate. Why minus sign? Because there is the decrement of mass within control volume. What will be the mass? Mass is nothing but rho into v. Okay, but for the control volume you are writing, so what is the small control volume? I mean, for the small quantity you have to write, and then you integrate, so for the full vessel you may get. Yes or no? So what will be the small value for the system control volume? It is dv. Dv is the elemental value. So this elemental value you have to write, and then you have to integrate, so you will get for the complete system. So here mass you may get, which is nothing but rho into dv. Yes or no? Rho into dv. But it is elemental volume. Dv is the elemental volume, so for the full control volume you have to integrate. So because it is the volume integral, so three volumes, three integral you will write. Okay, three integral you will write. Understood? Why three integral? Because it is a volume. Why this closed circle? If I am writing this circle, this closed circle will show you closed circle, no? In integration, closed circle means it is closed volume. That means closed volume means volume, it is not open volume, it is not open channel, it is closed channel or closed volume. Understood? Closed system. Not, don't say closed system, but you say like whatever the volume it is closed, it is not open. That's the meaning of it. Simple. Understood? So you got rate of decrement of mass within control volume. What you got? It is minus dou by dou t triple integration rho into dv. So dv is the small elemental volume. If you integrate, triple integration if you apply, then you will get volume for the full system. That's the mean of it, right? Now this is the equation number 1. Okay, when you are getting decrement, check the diagram figure 2. When you are getting decrement in the mass of the fluids mass decrement, why you are getting in figure 2? Because water is what going out. So now second equation you need to write. What it will be called? It will be called net mass flow, net mass flow out, huh? Or net mass flow rate, better, net mass flow rate, in bracket you would have write outflow, so that it should be very clear, because mass flow rate can be inflow also, but this is the outflow. That's the reason, if it is outflow then it will be decrement, if it is inflow then there will be increment. Simple first diagram, no? So through through cross section, through cross section. And what is the cross section? That is the surface area, because outflow or inflow always will be through the surface area, no? This is the surface area, surface area, because inflow will be surface area, I mean it will penetrate the surface, or the water will enter. So it mean there will be a one space, empty space, so that that water can enter. Okay, I mean it will cross the surface, that's the mean of it, simple. But for the volume increment or decrement, it is not going to cross the surface, that increment of mass or decrement of mass within controlled volume. You remember this terminology, okay? This explanation will not be asked in your exam, but this theory is very important. Question will be asked, you can answer. All right. Anyway, so through cross section. Now check. Suppose this is the cross section. Through this, water is what going out, na? So this is the outflow. Yes or no? Outflow. And you say this is the velocity vector v. Okay. Outflow from the. This is the cross section. Cross section. What is the cross sectional area? Elemental area ds. ds, yes or no? I have mentioned here, see, ds, elemental area. All right. Now what is the mass flow rate? Mass flow rate is nothing but rho area into velocity, yes or no? So you can write in terms of cross sectional area, I mean elemental area. What is the area here? ds. What is the velocity v? So I can write rho v into ds. But if you are writing net, so net means what? Net mass, no? Net means you have to integrate for the complete surface. So because this is the cross sectional area, I mean surface area, so area integration will be double integration. Single integration will be line integral, double integration will be surface integral, triple integration means volume integral. That you should know, yes or no? So here you will have double integration. This is equation number 2. Okay, always remember, if I am writing this, it means it is line integral, like this is what? Circle. Okay, double integral, this is called surface integral. You calculate the full surface like this. Okay, triple integration, volume integral. Okay, so volume integral means like you are going to calculate this. This is the volume integral. Okay, 3D. Understood? This is 3D. Okay, or maybe sphere, best example. This is what is sphere. Always remember. Anyway, so you need to write from equation 1 and 2. Now what is the one? because this magnitude wise it will be equal, right? Because whatever the mass is what entering, the same mass is going out, or whatever the mass is going out, the same mass decrement inside the control volume. So but amount will be the same. So that's the reason, as per mass conservation, I can write here as per per mass conservation, mass should be constant, it is not going to change. So first equation is what? Minus dou by dou t triple integration rho into volume is equal to this mass decrement inside the control volume, or rate of mass decrement in within control volume, equal to uh, the rate of flow, or mass flow rate, meaning is same, but it is through the surface area. So hence double integration, this will be rho v vector into ds. Okay, here you can write, take this dou by dou t is equal to this, or okay, or this is the equation, final equation I'm writing in vector form. This you can write, this is the vector integral form, right? This is the continuity equation in integral form. Fine. Okay, in integral form, yes or no? And this is not ended here. There is a different analysis. If you are going to write this in like vector form, so you can get equation from vector form. One more thing I just want to mention here, this area, because this area ds I need to write in format which is like important to tell what is the area. It is a scalar or vector quantity, this area ds. Suppose this is the area, no? Where flow is what going out, velocity vector v. So this area is what, scalar or vector? Any idea? Area is what, scalar or vector? It's a vector quantity. Okay, so what will be the direction? Direction will be perpendicular outward to the surface area. So your n cap is here. All right, so this vector quantity, if you want, you can give the vector. If you are not writing also, no problem, there will not be any effect on your result, but for the correction, I mean, it should be mathematically, it should be correct. So basically it is rho v vector ds, rho v vector ds, yes or no? Because it is the product. Okay, it is the product, so it's a dot product. Yes or no? So this is the final result in integral. Anyway, now again, if you want to write this in vector form, or as I told you, like differential form, Cartesian coordinate. Huh? So what you will do? You can write this like you have to give the statement a steady, unsteady. Okay, based on that, you can change the equation. So because again, one more thing you can do, like Gauss divergence you can use. So you can write this I mean Gauss divergence equation. If you use, then what is the Gauss divergence? Double to convert double integration into triple integration, so that you can further solve this. Okay, further solve this equation. What is the Gauss divergence in math? So Gauss divergence is nothing but is the one mathematical theorem in which what you have to do, you have to convert double integration into triple integration. Yes or no? So by, you can write here, by Gauss divergence theorem. What is the Gauss divergence theorem? So theorem, it is the theorem to convert surface integral into triple integral, or you can say into volume integral. Okay, this is the one theorem in mathematics. Okay, how to convert this? If double integration is what given in this way, f into dA, it is given double integration. Then how to write in triple integration? You have to write grad dot f vector into. So this is the one theorem. Okay, so again, no need to go for the proof of this, not required. It is theorem, so it is already proved in math, advanced engineering mathematics, HK Das, or any mathematics. If you check vector calculus, vector chapter will be there. So Gauss divergence theorem is given. Okay, so in our case, what, where is the double integration? See, double integration is what? Rho v vector into ds. Okay, you just say this is the dA vector. Okay, so it is like a v dot ds double integration. So how to write this? It's a simple only. You can convert this. You can write this. What you will write? Triple integration, then grad will come. Okay, grad dot, and this is nothing but rho is density, which is constant, so doesn't matter. And v vector as usual, check f vector here, so same thing, v vector as usual. Okay, and instead of dA you will get dv, so instead of ds you will get dv. Now it is converted by the Gauss divergence. So in this is equation number 3. So in equation number three, instead of double integration rho v ds, double integration rho v ds, you can write this triple integration grad dot rho v vector. Grad is the operator, vector operator. Okay, and I will tell you what is the meaning of grad. So this equation you can write now new rho by rho t triple integration check rho dv plus rho by rho t is given triple integration. What you got by Gauss divergence? You got grad remember this v vector is the velocity, okay, equal to v. Now this is the equation. Now this equation is what written in triple integration format. Yes or no? So here, or you can write, or take that dou by dou t and triple integration part, which is you can say uh, is like a common thing. So what we will write? Check. Now in this, wait. It is the only net is rho vds. There was no dou by dou t. See in this dou by dou t is not there. Why dou by dou t is not will be here? No, not required, because already this rho ab, if you write this, it is already unit is kg per second, mass flow rate. It is already a mass flow rate, m dot mass flow rate kg per second unit. If you check kg per second, so no need to write dou by dou t. Here it is okay, I have written correctly, but I think this next equation I had changed here. So this dou by dou t is not there. You have seen that previous unnecessary it is written, not required. Okay, by mistake it is written. That's the reason I thought why dou by dou t is coming. Understood now? Why? Because not required. Dou by dou t is not required for the mass flow rate because it is already unit is kg per second. If you check the rho AB, what is the rho? I'll show you. What is the unit of rho? Rho is kg per meter cube. Okay. Area meter square, velocity meter per second. If you check the unit, what you will get? Meter per second. So meter per second means already it is rate per unit time. No need to write again dou by dou t. Understood or not? So here I have not written. Here I have not written, but by mistake it is written in next slide. Huh? By mistake only, not required. Okay. So you just remove that part. By mistake it is written. I don't know how. Huh? So check. Here it's okay. Here it is not written rho VDS. Understood? But here also okay. See, here also okay. Rho VDS. Rho by dou t is not written. But next here I have written by mistake. So it was done by mistake. Understood? See, here also not written. Huh? Here also not written. But fine. So this is the equation. Now this equation, what you can do? Triple integration is there, you can remove that. Okay, right side it is equal, and so and it is a triple integration. That part you can remove. So what you will get? Dou by dou t rho volume. Okay, or do one thing that because volume is also both section you have volume, so that part also you can remove. Nothing to worry. The simplification I am doing. So only row you will have row. Okay, plus what you will have triple integration gone. Now you will have grad row. That dv also gone. Okay. This is the make it put in one box. This is what? This is continuity equation in vector form. Right. This is the continuity equation in vector form. Yes or no? This is the continuity equation in vector form. Alright. Now, integral form you have seen. This is the integral form. Check, this is the integral form. Yes. This is the vector form. Now, this operator, grad, in vector calculus or vector uh, that HK Das, Advanced Engineering Mathematics, it is given, I think, vector calculus name subject, topic name is vector calculus. So if you check this operator, this is the vector operator, what it is called? This is the vector operator, what it is called? Because this operator is basically uh, uh, if it is with vector quantity with dot product, then it will be called as a grad. Uh, okay, just you are writing the operator. I will tell you when it will be called a divergence, when it will be called a grad, when it will be called that curl, different conditions. I will tell you whenever it is required, but you just first go for the vector operator. So this vector operator is grad. What is the mean of it? Mean is I dou by dou x j dou by dou y k dou by dou z. Okay, and then there is the, yes, del operator. Correct, del operator. Okay, so when it will be called as a grad, divergence, or a curl, so this is the del operator, you are right, na? So I must say this is del, so there should not be, okay, del, fine. When this operator with scalar, then it will be called as a grad. Okay, when this is operator with vector, but with vector it is dot product, then it will be called divergence. When this operator again with vector, but it is cross product, it will be called curl. Example, suppose grad phi, delta and phi. Phi is scalar, okay, then it will be called as a grad phi. Okay, when this operator with the vector velocity v, no? Then it will be called as divergence v vector. When this operator is what cross product with velocity, then you will call curl v vector. Simple mathematics that you should know, no? Anyway, so whatever the vector, I mean, this you got here, this is very important, very important question they have asked. Okay, they have asked question, so one by one I will discuss because it is very interesting thing and important, na? Even if someone will go for the master mtech and all, so that equation will be used in different format, na? CFD and aerodynamics. So that's the reason I'm just explaining so that you will understand properly. Understood? And in gate also, small segment they are asking, I will tell you what they are asking. So now what you have equation, you have dou rho by dou t plus is equal to 0. This is what vector form, no? Continuity equation in vector form. Fine. You just open it. Once you open this, what you will get? As usual, dou rho by dou t plus what is the velocity v vector? It is ui vj wk, na? Coordinate system. This is I, this is j, this is k. I means x axis, y axis and z axis. In x axis velocity component is u, in y axis velocity component is small v, and in z axis I mean z direction velocity component is w. Okay, component. If you write capital V vector, so it means you are writing for 3D. Okay, if it is 3D, you are considering 3D, so all three component will come. If it is 2D flow, then only two component u and v, or u and w, or v and w will come. If it is 1D, then any direction u, v, w, anyone you can choose. Okay, so dou rho by dou. Here density is what? Density, it is a scalar quantity, so it doesn't matter, you can take outside or what, it's your choice. So here you can write I dou by dou x plus this operator I am writing j dou by dou y plus k dou y dou z. Okay, dot product rho. In velocity vector, what is that? V vector, so you can write ui vj wk, and right side it is equal to 0. Okay, take it. What you can write? Dou by dou rho by dou t plus I dot I will be 1. You know that I dot I 1, j dot j 1, k dot k 1. Yes or no? Simple mathematics. Nah? So here dou by dou x and I is with u. So you will get dou u by dou x, but rho vector is there. Yes or no? So you can write dou by dou x rho u. Similarly, you can write dou by dou y rho v. Then you can write dou by dou z rho w equal to 0. Yes or no? This is what? This is the continuity equation. Okay. Continuity equation in which form? Check, it is differential form. Yes or no? It is a differential form. This is again continuity. No? Vector form you have seen. This is the vector form here. This is the vector form. Yes. This is the integral form. Integral form done. Vector form done. Differential form done. And Cartesian, it is same, like you were writing equation in xyz coordinate, then it will be the Cartesian coordinate. Okay, now fine, then we'll go for the continuity equation in polar coordinate. In polar coordinate, polar means r, theta and z. If 3D you are taking, z it will come. If you are writing 2D only, then r and theta will come. Okay, so to hear that equation, this equation directly I will give. Okay, this is what z axis, this is r. Okay, and this is what theta. If you write component, v theta will be in theta direction, v component will come uh, like vr component, velocity vr component will be in r direction, v theta component velocity will come in theta direction, and z direction means perpendicular to this surface. This is what we did. You can imagine, na? R theta and z. Okay, so if you write the continuity equation in polar coordinates for 3D, what you may have, you may have dou rho by dou t as usual like previous, but from onward here it will be changed dou by dou r, dou by dou r rho vr. What is vr? It is radial velocity, plus rho vr by r. Okay, r is the radius, plus 1 by r. Okay, dou by dou theta into v theta. V theta is the tangential velocity, and dou by dou z rho vz is equal to 0. This is what vz is the velocity in z direction because it is 3D. So this is the continuity equation in polar coordinate. Okay, if you are going to write like 2D, then z component will be 0 for 2D. Yes or no? For 2D, z component will be 0. I mean vz and all. What you will have? Simple. Can write dou rho by dou t, dou by dou r. Yes, no? This is what continuity equation in polar coordinate. All right. So only one time they had asked, I think, polar coordinate. Not every time they are asking. But you need to remember, it's very simple. If you write 2-3 times, then you may get that. Okay. That story is not ended here. I'm just going to explore this continuity equation, like what type of question they are asking in exam. Now check. Simple. First of all, this equation, if you go for the steady unsteady, that last lecture I had explained, compressible incompressible. Okay, so question they are asking like write continuity equation for the incompressible flow, right? Continuity equation for which one is correct, for the which one equation for steady incompressible flow, what is the correct equation, like that option will be given to you. Okay, so one thing I will show you. So any equation you can take. I'm just going to take differential equation because it will be easy to understand. What is the differential equation? Check. Dou rho by dou t plus dou by dou x rho u. Rho v. This is the equation. Okay. Now if I say I will take one by one assumption. So if I say continuity equation for steady flow. Okay. If I say equation for steady flow. So for a steady flow, what is the steady flow? Anything taking derivative with respect to time, anything will be equal to 0. So here, this dou rho by dou t part will be 0 for a steady flow. So what will be the continuity equation for steady flow? It will be dou by dou x rho u rho v. This is the continuity equation for steady flow. Yes or no? I told you density is constant. That is true. Always constant. But sometimes it is changing. When it is constant, then it is called incompressible. When it is changing, then it will be called compressible. So if it is inside the bracket, I mean, if it is constant, then only rho you can take outside. Okay. If it is not constant, the rho you cannot take outside. Understood? Because it is in derivative. So again, one more assumption I will say. The same thing I can write. So continuity equation for steady and compressible. Okay, flow. Then what will be the equation? The steady you said it means dou rho by dou t gone. So it is compressible means density is not constant, so density you have to take inside. So this is steady compressible. Okay, but the same equation I can say uh, continuity equation. What I can say? I can say continuity equation for steady and incompressible. You can say like this. Yes or no? So incompressible means density constant. Yes or no? That means rho is constant. If it is constant, then you can take rho outside from the bracket and make it equal to 0 because right side it is 0. So what you will get? Dou u by dou x, dou v by dou y, dou w by dou z. This is what? This is steady and incompressible. Yes or no? Steady and incompressible. Now, this steady and incompressible, what is this actually? See, dou u by dou x plus dou v by dou y plus dou w by dou z equal to 0. What you can write this? Check. I told you dou rho by dou t will be 0 because you have said steady, right? Because you have said steady flow. So if you say steady meaning itself what? Anything with respect to time, that value will be 0. So that's the reason I made it 0. So once steady will come, then dou rho by dou t part will be 0. Huh? Dou by dou t part will be 0. That's the mean of steady, right? A steady only I explained. I study means last lecture I explained what is the steady and what is the unsteady flow. Yes or no? Right. So always remember once steady will come, immediately you have to make time derivative must be 0. Okay. Anyway, so I explained like that operator. It is what I dou by dou x plus j dou y plus k dou y dou z. And I explained what is the v vector. What is v vector? Ui vj wk. If I say this operator into v vector, I told you if this del operator will come with the vector, but if it is dot product, then what it is called? See, this operator dot product with vector, it is called divergence, no? So that means you are writing divergence of v vector. Check if you take the product. So I dot I will be 1, j dot j will be 1, k dot k will be 1, rest I dot j will be 0, I dot k will be 0, and all. Okay, so you have to concentrate I dot I, j dot j, and k dot k, because that will give the magnitude, no? So I dot I, where dou by dou x into u, so it means dou u by dou x. K dot k, where it is sorry, j dot j, so the j is here and j is here, it is dou by dou y into v, so it means dou v by dou y. K is here and k is here. Okay, so dou by dou z is here and w is here, so it means dou w by, so means divergence of v vector is equal to dou u by dou x plus dou v by dou y plus dou w by dou z. Now you can check dou u by dou x plus dou v by dou y plus dou w by dou z, this is nothing but what? Divergence of v vector. This is what? So this is asked in your gate, na? They are asking question very frequently in competition, like to write one day exam, ISRO or HAL exam. No? HAL notification out, if you have seen, no? The vacancy. I will give the notification page today. Good vacancy, you all have to fill the form. Okay, it is starting from 2nd of August and ending 22nd of August. So you have enough time to fill the form. All right. Anyway, so divergence of limit. This is GATE exam. They GATE question they had asked, and in I told you one day exam like ISRO, HAL, DRDO, they are asking question like, so for steady and incompressible flow, they will give option divergence v vector equal to 0, curl v vector is equal to 0, grad v vector is equal to 0, or grad v 0, none of the above. So divergence of v vector will be 0, because what is divergence? If you open it, you will get dou u by dou x plus dou v by dou y plus dou w by dou z equal to 0, and that is nothing but steady and incompressible. So always remember, guys, always remember, for steady and incompressible flow, continuity equation, what will be the continuity equation? Is nothing but divergence of the vector equal to 0, or and write this also. Okay, remember this is very important here. Okay, you make it mark, no? Very important. They're asking star mark. Okay. Anyway, so I hope you understood this. Okay, this I'm just that continuity equation